Hi folks, so this is question 9. So the first part, it gives you 3 patterns, so you can see what's happening each time there. The first one just has 1 dot and 1 x, and then the next one has 2 dots beside each other and then 4 x's underneath, and then the next one has 3 dots beside each other and 9 x's underneath. So what's happening with the dots is there's just 1 being added on to the right. What's happening with the x's is there's kind of 1 being added on to the right, and then everything underneath being added on as well, so 1 being added on underneath as well. So you should be able to see the next pattern. You're going to have 4 dots, so an extra one to the right, and then so the pattern 1 only had 1 layer of x's, pattern 2 had 2 layers, and then pattern 3 had 3. So pattern 4 is going to have 4 kind of rows of x's underneath. So that's basically going to be your answer. I could have had them a bit better aligned than that, but that's what you need to have. So find a formula in n for the number of dots in pattern n of the sequence t of n. So for the number of dots, so dots is easy enough. So in the first pattern there's 1 dot, in the second pattern there's 2, in the third pattern there's 3, in the fourth pattern there's 4, and so on. So that's basically your sequence. So it's probably the most simplest sequence you could have. It's just where there's 1 being added on each time. So here, plus 1, plus 1, plus 1 each time. So so the way I always find t of n, so what you're looking for is t of n, so it's just the nth term. So this is even junior cert stuff really. So the way I do it is just to remember, you do DINO, so you do the difference between the terms, and then you do n, and then you do the 0 term. So this is the one that comes before the first term. So the difference between the terms here is 1, and then you always put n automatically, and then the one that comes before the 0 term here, or sorry, before the first term, so the 0 term here will just be 0, because that has to be the one before 1 in the sequence. So it's plus 0. So 1n plus 0, 1n plus 0 is the same thing as just n. So n, or 1, you could have 1n if you want, or even 1n plus 0, but that's just your answer. So t of n is just n. Because think about it, if you want to know for the first term in the sequence, remember, so that's the first term, second term, third term, fourth term. So the first term is 1, second term is 2, third term is 3, fourth term is 4. So if I wanted to know t of 2, for example, then you put 2 in instead of n there, so it's just 2, isn't it? So if I wanted to know term 40, you just put 40 instead of n, so it's 40. So t to the n is just n. You don't need to show that, but it might be a bit confusing as to why it's just n. Okay, so find the number of dots in the first 20 patterns of the sequence. Yeah, so it's the total number. So for a total number, you're going to use the sum formula, sum of n. So s of n is equal to, for an arithmetic sequence, so n over 2 multiplied by 2a plus n minus 1 multiplied by d. D is the difference. So another way you could have done this was, you could just figure out what the first 20 terms are. So the first terms will be 1, 2, 3, 4, 5, 6, all the way up to 20. Those will be each of the terms, and then just add them together. So you're basically adding together the numbers from 1 to 20. But the formula for sum of, anyway, it's probably a little bit easier. So the sum of the first 20 terms will be, so n here will be 20. A is always the first term, so the first term here is 1, and d is always the difference between the terms, so the difference between the terms here is also 1. So it's just going to be 20 over 2 multiplied by 2 times 1 plus 20 minus 1 multiplied by the difference, which is 1. And then you could use calculator from there, or just work it out. So 2 plus 20 minus 1 is 19. So 2 plus 19 is 21. So 10 multiplied by 21 is 210. So that's your answer. The table shows the number of crosses for the first two patterns, so complete the table and hence find a formula for the number of crosses in pattern N. So first one there's 1, second one there's 4, so let's just double check up here. So the third one, there are 9 crosses, aren't there? If you count them all up. So 9, and then we can double check the fourth one as well. You might see a pattern here already, but just in case, you can check the one you drew out. So yeah, so if you count up these x's here, there's 16 of them altogether. So 4 rows of 4. So you can see what's happening here. They're actually all the square numbers. So you could even go and draw the next one out for yourself and count them again. But if you've spotted that they're all the square numbers, you should know the next square numbers are 25 and 36. So the number of crosses in pattern N. So again, t to the n here. It's just going to be whatever this is squared. So whatever 1 is squared here. So 2 squared, 3 squared, 4 squared, 5 squared. So it's n squared. So for t to the 1, you just do 1 squared. For t of 2, you do 2 squared. T of 3, you do 3 squared, and so on. So t of n has to be just n squared. So that's all you have to do. Find the number of crosses in pattern 12. Well, if you just follow on, then t to the n equals n squared. So therefore t of 12 has to be whatever 12 squared is. And you might know already 12 squared is 144. Find the number of shapes, so dots and crosses in pattern 10 of the sequence. So it's the number of shapes altogether. So for the dots, t to the n just equal to n. For crosses, t of n equaled n squared. So for the 10th pattern then, so pattern 10, t of 10 is just equals 10, so there should be 10 dots in pattern 10. And then for crosses, t of 10 equals 10 squared. So 10 squared is 100, so 10 times 10 is 100. So therefore there should be 100 crosses. So there's 10 dots and 100 crosses, so 10 plus 100 is 110, so 110. So that's it for all of part A. Part B then, the first two patterns in the sequence are shown. So the general term describing t to the n is n squared over 2 plus bn plus c. So use substitutions to write t1 and t2 in terms of b and c. So all you have to do here is for t1 you just need to put in what 1 is into it. So you're just going to put a 1 in instead of n. So t of n equals n squared over 2, so that it'll just be 1 squared over 2. So instead of n squared over 2, it's 1 squared over 2 plus b times 1 plus c. And then if you just tidy that up a bit, it's a half. So a half plus b plus c. And you can just write the half at the end if you want. You don't really need to. So it's b plus c plus 1 over 2. For t of 2, it'll be, instead of n squared over 2, it's 2 squared over 2 plus b multiplied by 2 plus c. So that will be 2b plus c plus, and then 2 squared on top there is 4, and 4 divided by 2 is 2. So that's your expression basically. So that's T1 and T2. Hence or otherwise find the value of B and the value of C. So if you look back here, I mean there's only one pattern, or sorry, there's only one X that's in pattern 1, and there's 3 that are in pattern 2. So T of 1 has to be equal to 1, and T of 2 has to be equal to 3, because it's basically this here is just kind of working out how many X's would be in any given pattern, or for any given term. So we're going to let T1, what we found for T1, the B plus C plus a half, let that be equal to 1, and we're going to let what we got for T2, so the 2B plus C plus 2, let that be equal to 3, because there's 3 X's up in pattern 2 there. So we're going to get 2 equations, and then we're going to be using simultaneous equations to solve. So B plus C plus a half is equal to 1, and 2B plus C plus 2 is equal to 3. So if I just do a little bit of work on this, if I move this half over to the other side, it becomes a minus a half, so 1 minus a half is just a half. So B plus C is equal to 1 over 2. And here 2B plus C, I'm just going to move the 2 over to the other side, so it becomes a minus 2. So 3 minus 2 is 1. So we get 2 equations here. Just to get rid of this half, you might not have to do this, but I'm just going to multiply across here by 2. So if I multiply everything there by 2, I get 2b plus 2c equals a half multiplied by 2 is 1. And you're allowed to do that as long as you do it to everything on both sides. So I've got 2 equations here. We're going to do simultaneous equations. So 2b plus 2c is equal to 1. 2b plus c is equal to okay, we get 1 as well here. So I'm going to multiply across the bottom by minus, just to make them all minus anyway, because we need a minus and a plus to cancel out. So 2b minus 2b is just 0, so the b's cancelled out. Then I've got 2c minus c, which is just c, and I've got 1 minus 1, which is 0. So I figured out that c is 0, and then I just need to figure out what b is, so I just take one of the equations on top or bottom there. So 2b, I'll pick 2b plus 2c is equal to 1. So if I just sub in a 0 in for c, because I know that c is 0 now, so 2b plus 2 times 0 is equal to 1. So 2b is equal to 1, and then bring across the 2 and divide, so b is equal to 1 over 2. So b is a half. So that's it. That's your final answer. So c is 0, b is a half.